Hi and welcome to my channel. Today I'm going to show you how you can solve the DNA problem from week 6 at HarvardX. This has been a highly requested video, so I decided to film it today. It may be a little bit longer than the others, but I don't intend to split it into parts because I don't think it's appropriate, especially for this one. So I'm not going to read the entire problem. I'm just going to briefly explain what it is. So we have a person's DNA, which is a sequence of STRs, and we are going to look inside of it to look for specific STRs and how many consecutive times they appear in this sequence. So, for instance, as you can see here, in Alice's DNA, the sequence AGAT appears exactly 4 times. In Bob's DNA, it appears 5 consecutive times, and so on. And then based on the longest sequence of these STRs, so in this case 4, in this case 5, we want to compare them with the real data and find whose DNA this is. So if we're given a sequence with 5 consecutive like AGAT STRs, then we have, let me check where this was. So if we have this table, or actually, okay, let's say that we have AGATC. We find it inside of this sequence. Let's say that we found it exactly 4 times. So we have AGATC appear 4 consecutive times inside of this sequence. Then this means that this is most probably Bob's DNA, even though we have to still check the other 2. But it cannot be Alice's, since it appears twice in Alice's DNA, but in this sequence, it appears more times, 4. So I'm going to explain that once more on my tablet, so don't worry about that. But this is the main idea, so we just have to find who the sequence belongs to. We have some specification, but actually, yeah, before starting writing the Python code, I'm going to go onto my tablet and just bring a little bit more clarification so that you understand the main concept here, and then it's going to be quite easy to implement this in Python. So let's take a look at my tablet. We have this sequence. This is sequence number 1, the one that I had open on my laptop. I've just brought it here, and we can also copy this table with the names and the STR counts of the different people. So this is going to be the small CSV file. I'm just going to copy it here. So we have 3 STRs which are being looked for. So AGATC is the first one. Then we have AATG, and then we have the last one is TATC. So something that we can notice right away is that not every sequence has the same length. Because if we do not take a look at that, and if we don't take it into consideration, we may try to, later on when we solve the problem, we may try to look for pairs. Let me bring another card, for pairs of 4, but it doesn't necessarily have to be 4. It could be 5, maybe it could be more. And okay, so that was something I wanted to clarify. And then we have 3 names. So the first one is Alice. The second one is Bob, and the third one is Charlie. Okay, so for Alice, we have 2 AGATC combinations appearing in her DNA, which means that if we take a look at Alice's DNA, the longest sequence of AGATC groups we'll find is 2. Then we have 8 times 8 ATG and 3 times TATC. Let me bring this like that. So then we have Bob. The STR AGATC appears exactly 4 times in Bob's DNA. So I'm just copying that from the CSV file. Don't worry if you cannot see it. I'm just copying it from there. He only has 1 AATG appearance, and then 5 TATC. And remember that these are consecutive appearances. They cannot be spread anywhere in the DNA. They have to be one after the other. and Charlie has 3 times AGATC, 2 times AATG, and 5 times DATC. Okay, so now before writing the code, let's just take a look at this DNA and try to guess whose DNA this is. So first, if we take a look at the first STR that's given here at the top, this one, AGATC. Let's look at how many times we can find it inside of this DNA. So AGATC. AGA, yeah, so nothing here. AGATC. I cannot find anything on the first line. Let's take a look at the second one. Okay, there we go. AGATC. 1 time. Then we start from the end of this one and we're looking for another one. So we have a second one, AGATC. Cool. Then a third one, AGATC. Let me draw it this way. Then a fourth one, AGATC. Now the next one is TATC, which is not the same, right? So this means that there are exactly 4 matches of AGATC. Now let's take a look at the data here. Which person has 4 consecutive appearances of AGATC? That's Bob, right? Which means that we can directly eliminate Alice, I'm not sure where to draw that, and Charlie, because they have a different number of AGATC appearances, which means that this is not their DNA. And now most students would conclude that this is Bob's DNA and return Bob. However, this is not the correct thing to do. The reason is that Bob may still have a different number of consecutive AATG appearances, for instance, and if that's true, then we may have no match. So no match is an opportunity as well. So we still have to check the other 2 STRs to make sure that this is Bob's DNA. So let me now take another color and look for AATG. So we have AATG. Oops, sorry. That's AATA, so it's not the same. Maybe I should bring this down a little bit, like that. AATG, right? It's even hard to find it. AATG. There we go. We have one here. Sorry, like that. AATG. Then the next one is different. So that's only one. And let's look for another sequence of these. Even though I don't think there is another one. AATG. Yes, that's the only one we can find here. So we have one sequence of AATG STRs in the original DNA we are given. So we've already eliminated Alice and Charlie, so we can take a look at Bob. And we can see that it appears exactly 1 time in Bob's original DNA. So yeah, this DNA sequence most probably belongs to Bob. But still we have to do the third comparison, which is TATC. Now let me take a green color, for instance, and look for this one. It should appear 5 times if this really is Bob's DNA. So TATC. I noticed that we have it once here, TATC. Second time, third time, fourth time, fifth time, and then we have something different. This is AGAA something. Now let's look if there's a longer sequence, even though there shouldn't be, but TATC. Okay. I don't think there's another one. So we have 4 times AGATC, 1 time AATG, and exactly 5 times TATC, which means that this DNA we're given here is Bob's DNA. So that's our main goal. That's what we want to do in our Python code. I hope you've understood it. If not, you can go back, or if you have any other questions, you can ask me in the comments or on my Discord server, which is probably the best option. Once we know this, we can go back to the specification and start writing code. By the way, I have already downloaded the resources. If you haven't, you can go to the beginning of the page of HarvardX week 6, and you can just follow those steps. I'm going to skip this and go to the specification. So, the program should require as its first command line argument the name of a CSV file containing the str counts for a list of individuals, and should require it as its second command line argument the name of a text file containing the DNA sequence to identify. If your program is executed with the incorrect number of command line arguments, your program should print an error message of your choice with print. If the correct number of arguments are provided, you may assume that the first argument is indeed the file name of a valid CSV file, and that the second argument is the file name of a valid text file. So let's directly go to the ID and implement this. What we expect is to get 3 arguments. The first one is the name of our file, the dna.py file, which I haven't created, by the way. So I'm going to create this file called dna.py. So yes, we have a couple of sequences. We are going to work with the first one now, but the code is working with all of them, and if you use it and if you run check50, it will pass all the tests. But for now, we will only work with that one. This is the original sequence of Bob. So we found out that this is Bob's sequence, DNA. Then we have a database with 2 tables, a small and a large one. For the purpose of this video, we are going to operate with the small one. We now have this dna.py file, which is empty. So let's start. The first thing we want to do is we want to check the number of arguments, and if it's incorrect, we want to throw some kind of an error. So first, what modules or libraries are we going to need? So we are going to need CSV, because we have this CSV file we want to be able to read. So import CSV. And we will also need the sys module in order to check for the arguments. Okay, so first, how do we take the arguments? We can say sys.argv, right? This has already been explained. I'm not going to go in details because David already explained it in his lecture. So if you are not familiar with those, you can go back, watch it, and then finish the piece set. So that's how we take the arguments. Now we want to know the number of arguments, so we can say the length of this, length, like that. So if we have 3 arguments, the length is going to be 3. And I'm going to say if the length is different from 3, this means that something's wrong, right? They could be less than they need to, or they could be more. So I'm going to print, and I'm going to use this message they had given as an example usage, and I'm going to give an example usage. So we expect 3 arguments. The first one is the current dna.py file. The second one is the CSV file we're going to use. It may be the small one, it could be the large one. And the third one is the text document, which has the original sequence we have to identify, right? So after doing that, we can say sys.exit1. So this means something went wrong, and we just stop the execution of the program. However, if everything's fine, so we have the right number of arguments, we want to read the DNA first, right? So the original sequence. So we have the sequence, and we want to identify whose sequence this is. So let's first store it in a variable. I'm going to say, and now you could either choose sequence or DNA. I'm going to call it DNA equals, and now I'm going to use open to open the file and read its content. So sys.argv to get the arguments. And now, which argument do I want to take? Let's take a look here. So we have first argument dna.py, second argument the CSV file, and the third argument is the sequence. So if I want to take the sequence, I need the third argument, right? But recall that in programming, we start from index 0. So we have 0, 1, 2. So this is 0, this is 1, and this is 2. So in this case, I'm not going to say sysargv of 3, but instead I'm going to use 2. Okay, and I want to use the reading mode because I'm only going to read the sequence. I'm not going to modify it in any way. And then I'm going to say read. Okay, so now I've stored it in a variable. I want to also, let me just remove this because otherwise it's not going to work. I want to also open the CSV file, right? Because we want to take a look at the different STRs, the number of times they appear inside of the sequence, and then identify the person whom it belongs to. So I'm going to come here and say, now I'm going to use with open so that I don't have to close it manually. David has explained that as well, so if you want, go back to his lecture. And this time I'm going to open argv of 1, right? Because this is the second argument, and since we start from 0, we have 0 and then 1. And I'm going to say s CSV file. Okay. Now, once we have this, everything which is indented from this, so one tab to the right, is going to be done when the file is open. And if we have anything else on the previous ident, like this is going to be executed after the file has been closed. But now, since we want to operate within the file when it's open, I'm going to go one tab to the right. This is very important in Python. Okay, so the easiest way to read this CSV file is by creating a dict reader. Again, this is from the last lecture, so you can watch it. I'm going to create a new variable. I'm going to say reader. You could say data reader, sequence reader, whatever it is, equals CSV dot, and now the method is called dict reader in Pascal case, dict reader, like that. And then I want to enter the file, which is CSV file. So these have to match, right? This is the name of your file, and you want to convert it into dict reader. Okay. And now we already have access to this sequence and this table here. Okay. So first, let's try to find out which STRs we are looking for inside the sequence. So we have the sequence, and we want to look for particular patterns, right, which are called STRs. And in this case, with the small SCV file, we have AGATC, AATG, and TATC. So how can we get these? Now, these are kind of like the headers, right? So this is the header, and then for every person we have a certain number, it appears, right? So how do we get the headers? Well, there is this method called field names, which we can apply to a dict reader. So I'm going to say headers equal reader, because we have already seen the dict reader inside this variable. So reader dot field names, which is going to give us the headers again. And let's print it. Print headers. I'm going to save. I'm going to bring this terminal to the right. And I'm going to copy this usage from here, but I'm just going to change it. So I'm going to use the first sequence, like I said, and the small CSV file. Okay, there we go. So we have name, AGATC, AATG, and TATC. Now, we don't really care about the name. We know that we will have some names listed, but for now we only want a list with the STRs, right? Because then we want to try to find them inside of the original sequence. So I'm going to come back. I'm going to remove this. I'm going to rename this variable. I'm going to call it, let's say, STRs tested. So these are the STRs that have been tested and that we're looking for. And in order to remove the name, I want to start in index 1 and go to the end, right? So I'm going to use the square bracket syntax, and I'm going to say start from 1, then colon, and go to the last one. So since I want to go to the last one, I don't even need to put an n index, right? I can just say, like, take this list and cut it from the first one, from the one at position 1, index 1, to the end. So now, if I come here and say print strs tested, and run it once more, I can see that I've successfully obtained the names of the STRs. Okay, that seems to be all good. And now there are really a lot of approaches we could take here, but the one I'm going to use is I'm first going to go through this sequence and find how many times each of the STRs appears. So that's pretty much the same as what I did on my tablet, right? First I took the first STR, HGATC, and I went through the entire sequence and found exactly how many consecutive times it appears. And then I took the second one, I found how many times it appears, then the third one, and so on. So, in this case, what we want to do is I'm going to create a dictionary, which is going to be called STRs. Let's say STRs count. And in the beginning, it's going to be an empty dictionary. So what I'm going to keep in here is I'm going to have something like this. So the first one is AGATC, right? AGATC. And then as a value, I'm going to say how many times it appears. For instance, 1. Then I'm going to have the next one. So it's going to be AATG. And then how many times does it appear in the original sequence I'm looking at? Let's say 4. 4. And the same goes for the others, right? So I want to fill this in, but how do I do that when I don't know how many times it appears? Okay, so that's all good. Now we're going to use a for loop to go through this sequence and find the longest consecutive sequence of this STR. So I'm going to say, for every STR, I'm going to capitalize it because if I use it this way, it's going to be interpreted as if I'm trying to use the type string, but this is STR. So for each STR inside of this list, I'm just going to print it, okay? Like that. And let's try this to make sure it works. Okay, perfect. So we had this list, and I'm saying for each element inside of this list, which I called STR, just print it, right? Okay, that works. Now what do we want to do here? So first we're going to have some kind of an index, because we want to be able to navigate through this and know where we've started, where we currently are, where we want to end, etc. So I'm going to create a new variable. I'm going to say index equals 0. 0. So I start at the beginning of the sequence, right? And now what do we want to do when we start at the beginning? I'm also going to set up another variable, by the way, which is going to be called longest sequence, right? Because we may have something like that. We may have, if we're looking for AGAT, okay, we may have AGAT once, AGAT twice, then something else, then AGAT, I'm going to explain this now, AGAT. So the first time we have 1, 2, and we may think that 2 is the longest sequence of AGAT, but it's not, because if we continue, we can find that we have it 3 times here. Once, twice, and this is the 3rd time. So we have to kind of go through the end to the end in order to be able to determine what the longest sequence is. So in the beginning, since we haven't gone through any kind of STRs, we're going to have the longest sequence equal to 0, right? But then we're going to change this value when we find some sequences of the current STR. So I'm going to say while the current index is less than the length of the DNA. So what's the DNA? This is the entire sequence, and we just want to make sure that that when we reach the end, we don't try to find any more sequences. So we go through from 0 to the end, and then let's see what we are going to have. So I'm at index 0. What do I want to do? So how am I going to take this these sequences. So let's say that I'm looking for AGATC. Now what's the length? It's 5, right? So if I come back here, I'm looking for, I want to take the 5 consecutive letters. So 1, 2, 3, 4, 5, right? I hope you can see the highlighted part, even though it's not that different, but it's in gray currently. And now I'm asking, is this AGATC? No, it's not, right? And if it's not, I want to start at the second one now. So I'm highlighting 5 of them because that's the original length of this str. Now, is this AGATC? No. Then I go to this one and so on. So this is a very beginner-friendly approach. Of course, there are better algorithms you can come up with. This is going to be very slow, but since you're beginners, I think this is going to be the optimal approach. Okay. On the other hand, let's try to find one AGATC. So we are looking for AGATC. Okay, so we have it here, right? It starts here. So if we take 5 letters and we ask, is this equal to what I'm looking for? Is this AGATC? Yeah, it is, right? And in this case, we don't have to start at the next letter. I mean, when we have, okay, let me write it here, like that. So if we've gone through the first 5 letters, we want to start at the next one, right? And now, is this sequence of 5 letters AGATC? Yes, it is. Then we start in the next one, which is again an A, and go to the end. So I know you may find this a little confusing. Don't worry, you can go back. This really is a complex problem for beginners, so don't worry. But what I'm going to do is I'm going to say current str, or current sequence, doesn't really matter, equals, and I'm going to take the DNA. So I'm going to take the sequence and cut it from the index to index plus, and now you may say 5 or 4. But recall that in the beginning of the problem I explained that these have different lengths, right? So we cannot be sure that all of the sequences are going to be 5 letters long or 4. So I'm just going to say the length of the current str. So str. Okay? So if the index is 0, we start here. Sorry, let me go back. And we cut it from index 0 to index plus 5, if that's the length, right? So we want to take the first 5 letters and so on. So I'm just going to say, if I say print current str, okay, so we cannot print it yet. But we have cut a certain piece out of our DNA, and now we want to see if it's the exact same str we're looking for. So is this equal to AGATC, right? So I'm going to say if the current str is equal to the str we're looking for, right? The one we're testing, then I want to say, so I'm going to add another variable, which is going to be called current sequence, or current longest sequence. It doesn't really matter, but I'm going to call it current sequence, equals 0. So now I'm going to say plus 1, right? So up to this point we have found 0 matches, but now we have found 1. So we want to increment it. And I'm going to say current sequence plus equals 1. Okay? Now we have found the AGATC match. And what happens when I found a match? I want to start at the next index, right? So we've cut it from 1 to 5, from 0 to 5, and then we want to start at 6 to take a look at the next one. I really hope you can see that. I'm not sure if you can see when it's highlighted. I'm going to put some spaces. So check this one, and then we want to start at the next letter. Check the next 5 ones, and then so on. So I'm going to come back, and I'm going to say index. I've got used to using I, but in this case I'm using the index variable, plus equals the length of the string, right? By the way, you can take this out in a variable. So if I'm looking for 5 letter 5-letter str, and I have this. My index is 0. I cut the first 5, and if it's a match, I want to start from the next one. So 0 plus 5 plus the length is 5, and I want to start at the next one, right? So that's how it works. And what do you do if it's not a match? So let's say that I have something wrong here. If it's not a match, let's say I'm taking this one, CAGAT. Is this a match? No, it's not, right? Because this is not the same as the one I have here. Well, in this case, I want to check the next one. So I want to start, I don't want to start from the end of the sequence, but I want to start from the second letter. So in this case, I'm going to say index plus equals 1, right? So this is invalid, and we want to check the next one. We want to push it 1 letter to the right and check the next sequence that comes up. But we also have to do something else. If the current string is different from the one we're looking for, or the current str, sorry, then we want to this means that the sequence is broken, right? We may have found 3 matches, but then we have the 4th one is not a match, and we want to break the sequence. So I'm going to say the current sequence is now equal to 0. Like the chain is broken, and we go back to 0. If we find some more later on, we can add them, but for now it's over. However, before that, there's one last thing we want to do, and that's to check if the current longest sequence is actually longer than the previous one. So let me give an example here. We may have, let me just remove this from here because it will mess up how it works. So I'm going to create a new one. AGATC, AGATC, then CCTA, and then CCTA, T, and then AGATC. So let's split it in groups of 5. 2, 3, 4, 5, like that. Sorry, I'm going to do it this way. Okay. So first, we have 1 correct sequence, 1 match, 2 matches. And now the longest sequence is 2. Then we have a mismatch. So the current sequence is broken, and we start over from the next one, right? And now we count 1, 2, 3. So now I have a new longest sequence. What's the longest sequence? It's 3, not 2, right? It's not always the first one we find, but the longest one. So let's say we're here and we have current sequence equals 3. And if the current sequence and the previous longest sequence was 2, right? And the current one is 3. So if the current one, sorry, I've misspelled sequence here. The current sequence is greater than the previous one, than the longest sequence. Sorry, I forgot to add if here. If this is true, then I want to say the longest sequence now equals the current one. So I know that may be confusing. I'm going to explain it once more here. So the current sequence 1, 2. So the current longest sequence is 0, and the current sequence is 0. And now we start going through those. Is this a match? Is this AGATC? Yes. So this gets to 1. We have a sequence of 1 consecutive match. Then is this a match? Yes, it is, right? So the current sequence gets to 2. Then we have a mismatch. So when we meet a mismatch, we first want to ask, is the current longest sequence longer than the previous one? So is the second row here greater than the first one? Yes, it is, right? So we want to update. Now we have a new longest sequence. It's 2. But since we've met a mismatch, this gets to 0. We are going back to 0. Okay, so this is a mismatch. But is this a match? Yes, right? So the current sequence is 1. Then is this a match? Yes, it is. So this gets to 2. And the third one is a match as well. So this is 3. We have now found a new longest sequence. So you want to update this as well. This gets to 3. So the longest sequence of AGATCs we found here is 3. Okay. Let me now remove this. I hope you've understood it. And we can go back here. We've now done that. And we're pretty much done with the while loop. And now, once we get out of it, so we've gone through the entire sequence, the entire DNA of that person, and we have found the longest sequence of repeating STRs. We can set it into this dictionary we created, right? So I can say STRs count of the current STR equals longest sequence. So basically with this I'm saying go to this dictionary and say that the longest sequence of AGATC, for instance, is 3, right? Or the longest sequence of ATAC is 5, etc. This is going to be replaced by whatever the current STR is. So if it's AGATC, we're going to go here and say AGATC, and then the number, the longest sequence, which is 3, for instance. Okay, we're done with this, and we can safely go out of this for loop, right? In the while loop as well. I think the harder part's done, by the way. Now, what we are left with is that we want to go through the people. So we already have this STRs count dictionary, but let me just print it here to make sure it works well. So STRs count. I'm going to save it here, run this. Okay, so that's what we've created up to this point. We've gone through the entire sequence, and we found that we have 4 consecutive AGATC appearances, only 1 consecutive AATC appearance, and 5 TATC appearances. And once we know this, we can go through the people and say, does this person AGATC number match this one? So is it 4? Then is the AATG number 1, and then is the TATC number 5. So let's go back, and I'm going to create a new for loop, but this time we're not going to iterate through the STRs, but through the people. So I'm going to say for each STR in, for each person in the reader, because the reader has the people data, right? And for now, I'm just going to say print person. Print person. I'm going to leave this print STRs count so that you can see it. So let me run this. And now first we see the number of AGATC and other STR matches, and then we see the people. So basically what we're doing is we're saying, does Alice's number of AGATCs match the original one? So are 2 and 4 the same? No. So this cannot be Alice's DNA. But then we take a look at Bob. Does Bob have the same number of AGATC consecutive appearances as the original one? Yes, 4 is equal to 4. Now these are strings, these are integers, we can fix that. Then does he have the same number of AATGs? Yes, it's 1. And does he have the same number of TATCs? Yes, 5. So this is Bob's DNA. So let's do that, and it's going to be over, I promise. I know you may find it difficult now, but when you watch it a couple of times, it's going to get more clear. And for every person, I'm going to take the name first. Okay, so I'm going to say name equals person of, and so the name of the person. So go into each of these objects and give me the value of the name. So what's the name here? Alice. What's the name? Bob, etc. Okay, I have the name. So now we need access. We want to go through all of the STRs and check what the person's value is. So I'm going to say for each STR in STRs tested, right? We already have them. So STRs tested. I want to print STR. Just check if everything's fine. Okay, so we see them a couple of times because we have 3 people. And now we have the STR, and we want to say if person STR Sorry, I don't need these brackets. I come from a JavaScript background, so I usually tend to use brackets even when it's not needed. But in Python, you don't use brackets with if statements. So let me just go back a bit and just print person, because you may have forgotten what person is. So print person. Okay, so something went wrong. We have wrong indentation. Yes, I'm going to remove it for a bit. Okay, and now I'm going to come here and say for each str inside of inside of strs tested, I want to print str, or I'm not going to print it, but I want to check if the value inside, so if the number of AGATC here is the same as the number I have found inside of the sequence. So I'm going to say if person of str, so go to person and give me the value of the current str, for instance AGATC, so it's 2, but notice that this is a string, so if you want to convert it into an integer, we want to use the int method. So I know all of these are confusing, don't worry, like seriously, it's not your fault, it's just quite complicated for beginners to grasp. But essentially I'm going to this object, and if str is currently AGATC, I'm saying give me the integer value of AGATC, so that's 2, right? Or AATG, which is 8. And I'm saying if this number is if it's different from, I'm going to explain this now, str's count str, then print wrong number. So I'm going to explain this now. I just want to also print str's count. Okay. Okay, so here's what's happening. We have this number of matches, and we essentially what we're doing is we're asking, for instance, if we're at Alice, we're comparing the numbers for AGATC. So is 2 equal to 4? No. So if 2 is not equal to 4, this means that we can know for sure that this is not Alice's DNA. So I can say here, so if they're different, then actually we need another variable. So I'm going to create another variable here. I'm going to call it isFound. It's going to be Boolean, so it's either true or false. And in the beginning, it's going to be true. Now I know this may sound a little bit ambiguous. The reason is that in the beginning, since we have not tested anything, we believe it's right, but then if they're different, then we're going to convert it to false. So in the beginning, we assume that the person is the same one whose DNA has been tested. But if there's a difference in the numbers, then we say isFound equals false. So this person is not the correct one. And we can break. So we're going to go out of the for loop, because if one str, so if let me go back here. I'm going to remove this. I'm going to remove. Where is that? Yeah, I've already moved it. Okay, so I'm going to come here. So if Alice has a different number of AGATC, there's no point in comparing the other two. We already know that it's not Alice, right? So that's why I'm breaking. I'm saying don't check for the others, the other STRs. Just continue with the next person, right? But on the other hand, let's see what happens if we have Bob. So for Bob, we come here on this line, line 41, and say, is Bob's number of AGATC the same as the original one? Yes, it's 4, right? We want to continue, so we're going to skip this, and we're going to continue with the next STR. So, is Bob's number of AATG equal to the original one? Yes, it's 1. Then is Bob's number of TATC equal to the original one? Yes, it is. It's 5. So in this case, what we want to do is after we've tested all of the STRs. So we've gone through all of them and we haven't changed the value of is found. So if is found, we want to print, let me check what it was. So we just want to print the name of the person. And I'm also going to say sys exit 0. So everything was fine. I found the right person and I'm just ending the program. So if there is no single STR which is different from the original one, we can confidently declare that Bob's the right person or whoever it is. And we can exit the program. Otherwise, if we go through all of the people and we don't find any person whose number of STRs matches the one in the original sequence, we just want to say print no match. So that was pretty much it. Now I have to test, of course, but I think we're done with the main part. This should work. Now this problem is extremely confusing. I'm aware of that, don't worry. Again. Let's test it. We should see Bob, perfect. And let's directly run check 50 to see if it works. So as you can see, all of the tests have passed, which means that our program works correctly. Now, if you have any questions, which you most probably will, feel free to enter my Discord server. We can discuss this problem. If there are enough people, we can even conduct a meeting where I'm going to re-explain some parts you don't feel confident in. But again, it's normal to feel overwhelmed by this problem. That's why it's considered a more difficult problem. It really is, especially for beginners. But especially if you try to solve it by yourself, you're going to see that it will start making sense. So that was everything for this video. I really hope it's been helpful. We can run style 50, but if there are any errors, they're really easy to fix, so I'm not going to do it now. So that was everything. I hope you liked my video, and I'm going to see you in the next tutorial.